Good afternoon, everyone, and welcome to Q&I summer course. So students, let us start the class. So again, good afternoon, students. So I'm Sunit Kumar, your mathematics tutor. So students, I'll start a new chapter today, that is polynomials. That is the second chapter of your NCERT. So we had completed the first chapter, real numbers, in the previous class. And let's start the second chapter today. Okay. So as I said, we'll start with a new chapter, that is polynomials today. And the prerequisite for this chapter is the understanding of algebraic expressions. You should know what algebraic expressions are. Then you should understand the degree of a polynomial, how to find the degree, what is degree of a polynomial. Then you should also know the types of polynomials. Fourth is the value of the polynomial at some particular value of the variable. And last is zero of a polynomial. So all of this you have already studied in class 9th. Degree of a polynomial, types of polynomial, value of a polynomial, and zero of a polynomial, right? So an algebraic expression you have already done in grade 8. So we'll try and recapitulate everything before we start grade 10 syllabus of polynomials. So today what we are going to do in class is to understand geometrical meaning of zeros of the polynomial. So what does zero of a polynomial signify geometrically? So we'll see that. Now let's start the chapter. So what is a polynomial? Let's understand that. So let x be a variable and n be a positive integer, and as a1, a2, a3, an be constants, that are real numbers, then polynomial px can be defined as an x raised to the power n, an minus 1 x raised to the power n minus 1, and it continues up to a1 x plus a naught. So this is called polynomial in variable x. So in this polynomial, all of these terms an xn, an minus 1 xn minus 1, these are all called the terms of the polynomial, right? Now, in the previous grade, we have seen if there is only one term in the polynomial, we call it monomial, right? So if there is only one term, we call it monomial. If there are two terms, we call it binomial, right? So number of terms, you can divide polynomials in different types according to the number of terms. So if there is only one term, we call that polynomial a monomial. If there are more than one terms, we have two terms, then we call it binomial. If we have three terms, we call this polynomial trinomial. So there will be three terms, right? And in general, these are called polynomials. Is it clear? Okay. Let's go to the next. Here an minus 1, a1 and a naught, these are called the coefficients of a polynomial. Okay. a0, a1, an minus 1 and an, these are called coefficients of the polynomial. Okay. Now, there are certain algebraic expressions which are not polynomials. So expressions like 2x square minus 3 root x plus 5. Similarly, 1 by x square minus 2x plus 5. These are not polynomials. Why? Because in the polynomial, the powers of x should be whole numbers. It cannot be the powers of x cannot be a fraction or a negative number. So since the powers of x are not whole numbers, for example, here the power of x is 1 by 2. Similarly, in this case, because x is in denominator, the power will be negative. So the power of x should be only whole number for that expression to be a polynomial. So since if the power of x is either a fraction or a negative number, then we say that that algebraic expression is not a whole number, not a polynomial, which you are seeing in the two examples which are mentioned here. Is it clear, students? Are you clear on what polynomials are? What are the terms of a polynomial? How you can divide polynomials in different types according to number of terms of polynomials? Third, we also saw what are coefficients of each term. And fourth, we saw that what are the algebraic expressions which are polynomials and which are not polynomials. Is this clear to everyone? Okay, good. So Raghavi, Ellen, and Devi Maya and Ragul. Only 4 students today. Okay. So Ellen, is it clear to you as well? Let's go ahead. Now, degree of a polynomial. The exponents of the highest degree term in a polynomial is known as its degree. For example, if you have, if you have 2x cube plus 3x square plus 6x plus 7. Now, in this polynomial, we know the exponent of highest degree term. So this is the highest degree term. And the exponent is 3. So we will say that degree of this polynomial is 3. Now, second, the highest power of x in a polynomial px is called the degree of a polynomial px. This is another way of stating this. For example, here in gy equal to 2y square minus 3 by 2y plus 7. So g is the name of the polynomial and this y represents the variable which is there in the polynomial. So here in this polynomial, you can see the highest degree term is 2y square and the exponent here is 2. So that's why we say that degree of the polynomial is 2 in this case. Is it clear to everyone? You have understood what degree of a polynomial means? Okay. Now constant polynomial. A polynomial of degree 0 is called a constant polynomial. For example, if we have a polynomial px is equal to 7, this is a constant polynomial. Why? Because we can write this as 7 times x raised to the power 0. X to the power 0 means 1. So this will be 7 into 1, which is 7. So here the highest degree term is 7x0, and that's why we say that degree is equal to 0. So degree of a constant polynomial is 0. For example, px is equal to 7. Here the constant polynomial px is equal to 7 has a degree 0. Now, there is another constant polynomial px is equal to 0. So px is equal to 0 is a constant polynomial which is called a zero polynomial. This constant polynomial has a special name which is called zero polynomial, and the degree of the zero polynomial is not defined. Why it is not defined? Because 0 times x to the power 0 will be 0. Similarly, 0 times x to the power 1, this is also 0. 0 times x to the power 50, this will also be 0. So because these are all 0 polynomial, but the highest power here is 0, here it is 1 and here it is 50. So it is not defined. The degree of 0 polynomial is not defined because it can be anything. Is this clear, students? Is this concept clear? Why the degree of 0 polynomial is not defined? Because x to the power anything multiplied to 0 will give you 0. So that's why degree of 0 polynomial is not defined, and degree of a constant polynomial is always 0. Okay, great. Let's move to the next one, students. Linear polynomial. Now let's understand. So there are different types of polynomials which we are going through. First was constant polynomial. Now second is linear polynomial. Now, what are linear polynomials? A polynomial of degree 1 is called a linear polynomial, right? So, a polynomial of degree 1 is called a linear polynomial. For example, px is equal to 4x minus 3. So, this is a polynomial whose degree is 1. The power of x is 1, right? So, polynomial of degree 1 is called a linear polynomial. So, here the power of x is 1. So, we call this as linear polynomial. The general form of a linear polynomial is of the form ax plus b. So the polynomial of the form px is equal to ax plus b, where a and b are real numbers. The coefficients are real numbers. So this will be a linear polynomial. Is this clear, students? What are linear polynomials? So polynomial of degree 1 is called a linear polynomial. And the general form is ax plus b. Now let's see quadratic polynomials. What are quadratic polynomial? A polynomial of degree 2 is called a quadratic polynomial, right? So a polynomial of degree 2 is called quadratic polynomial. For example, px is equal to 2x square plus 3x minus 4 by 5. Highest degree term is 2x square and the exponent here is 2. So degree here is 2. The general form of a quadratic polynomial. So general form of a quadratic polynomial is ax square plus bx plus c, right? Where a, b and c are real numbers. Is this clear? Now cubic polynomial, a polynomial of degree 3 is called a cubic polynomial. Example, px is equal to 4x cube minus 3x square plus 2x minus 1 by 3. So here you can see 4x cube, the highest degree term is 3 here. So we say that degree of this polynomial is 3 and that's why this is a cubic polynomial. The general form of a cubic polynomial is ax cube plus bx square plus cx plus d. This is the general form of cubic polynomial, where a, b, c and d are, are real numbers. The coefficients are all real numbers. Okay. Now fourth one is biquadratic polynomial. So what is the degree of biquadratic polynomial? Who is going to tell me? Yes, the degree is 4 for biquadratic polynomial. Good, Raghavi. So a polynomial of degree 4 is called biquadratic polynomial. For example, 3x4 plus 2x cube plus 4x square minus 7x minus 1. The degree here you can see is 4. So that's why this is a biquadratic polynomial. General form of a biquadratic polynomial. So general form of a biquadratic polynomial is ax4 plus bx cube plus cx square plus dx plus e, where a, b, c, d and e are all real numbers. The coefficients are all real numbers. Okay, just note this down, biquadratic polynomial, because linear, quadratic and cubic you may have already learned about it in class 9th. Biquadratic is something new, so you can note this down. Biquadratic polynomial has a degree of 4. Clear? Shall we move ahead? Okay. Now value of a polynomial. So if px is a polynomial and alpha is any real number, px is a polynomial and alpha is a real number, then the real number obtained by replacing x by alpha, if we replace the value, wherever you have x, if you replace it by a value alpha in the polynomial px, this is called the value of px at x is equal to alpha and it is denoted by p alpha. So let's say px is equal to ax square plus of, so let's say px is ax square plus bx plus c. Then p of alpha will be a times alpha square b times alpha plus c. So instead of x, what we are going to do is we are going to replace it by alpha. So this is called value of the polynomial px at x is equal to alpha. So this is value of polynomial px at x is equal to alpha. When you replace the variable x by some real number alpha in the polynomial px, then we say that this is the value of the polynomial px at x is equal to alpha, and it is denoted by p of alpha. Is this point clear, students? You have understood this? So one more example, let's say we have a polynomial px is 2x square plus 3x plus 1. Now, if we have to find the value of the polynomial p of 1, means value of the polynomial px at x is equal to 1. So this will be 2 times 1 square, 3 times 1 plus of 1. So 2 plus 3 plus 1. So this is 6. Value of the polynomial px at x is equal to 1 is 6. P of 1 is 6. Yes, Raghavi, it is correct. It was 6 only. Is this clear to everyone? Till this point, I hope it is clear to everyone and you have understood everything. Any doubts you are having till now? Ellen and Devi Maya, is it clear to you as well? Okay. Now 0 of a polynomial. So that value of x for which the polynomial px is equal to 0 are called 0 of the polynomial. So a real number alpha is a 0 of the polynomial if p of x, 0 of a polynomial px if p of alpha is equal to 0. If the value of the polynomial at x is equal to alpha, if it is equal to 0, then that value of the variable x, that is x is equal to alpha, is called the 0 of the polynomial. Clear? So finding a 0 of a polynomial px means solving the polynomial equation px is equal to 0. For example, if we have a polynomial px is equal to 2x plus 3, if I have to find the value of the polynomial at which this is equal to 0. So we are going to equate this to 0. We will get 2x is minus 3 and x is equal to minus 3 by 2 will be the 0 of polynomial px is equal to 2x plus 3. Clear? Linear polynomial px is equal to ax plus b has only one 0, right? And this is given by alpha is equal to minus b by a, that is constant term, negative of constant term by coefficient of x. So to find this, what we did is we equated that to 0 and we got ax is minus b or x is minus b over a. Okay. So x equal to minus b by a, that is your 0, which is negative of what was b? B was the constant term. So negative of constant term divided by what was a? A is coefficient of x. So this is how you find the 0 of the linear polynomial. Is it clear, students? Have you understood this? Okay. Now graph of a linear polynomial. How to draw the graph of a linear polynomial? This you have already done in class 9th when you were drawing the graph of linear polynomials, right? Now, graph of a linear polynomial, let's say we have y is equal to 2x plus 3. The polynomial px is equal to 2x plus 3. What we do, we write this, we take the value of the polynomial on y-axis and the value of the variable on x-axis. So y is px, which is 2x plus 3. Now we plot at different values of x, we plot different values of y. So x is equal to minus 2, y will be minus 1. X is equal to 2, y will be 7. And you can have different values. Let's say at x is equal to 0, you will have y equal to 3. So you will plot these 3 points. So this is minus 2 comma minus 1. This is your point minus 2 comma minus 1. Then second point is 0 comma 3. Second point is 0 comma 3. And the third one is 2 comma 7. Then once you have got these 3 points, you will join that straight line. Because it is a linear polynomial, the graph is going to be a straight line. So this is, and then you can see here that these 3 points lie on a same line, lie on a straight line. So this is going to be your graph of the linear polynomial y is equal to 2x plus 3. Is it clear, students? Have you understood the concept? The graph of linear polynomial? Okay. So the value of x and y can be found out randomly by trial and error method. You will put different values of x and you will get different values of y, and accordingly you will plot that in the graph paper to get the straight line representing that linear polynomial. So graph of a linear polynomial is always a straight line. So graph of linear polynomial is always going to be a straight line. Right? Let's move ahead. Now, geometrical meaning of the zero of a linear polynomial. What does geometrical meaning means? So in general, so I'll show it to you in this only. So geometrical meaning is, you have this polynomial. Now we say that the value of the polynomial equal to 0. The value of variable at which the value of polynomial becomes 0 is called 0 of the polynomial. So when will this become 0? Means y is 0 at this point, right? So this point minus 3 by 2 comma 0 is the 0 of the polynomial. So the value of x is minus 3 by 2. So this is the 0 of the polynomial. Is it clear? So the graph where it cuts the x-axis, any graph when it cuts the x-axis or touches the x-axis, the point at which it cuts the x-axis or touches the x-axis is the 0 of the polynomial. So that is what the geometrical meaning of 0 of a linear polynomial is. So in general, for a linear polynomial, ax plus b a not equal to 0. The graph of y is equal to ax plus b is a straight line which intersects the x-axis at exactly one point, namely minus b by a comma 0. Because when you equate this ax plus b equal to 0, x is going to be equal to minus b by a. So this is that value at which you get a 0 of the polynomial. So x is minus b by a and y at that point will be 0. So minus b by a comma 0 is the point at which this linear polynomial graph cuts the x-axis. Is this clear, students? Are you able to understand this geometrical meaning of the 0 of a linear polynomial and how to calculate this, how to find it? What is its geometrical significance? Okay, great. Let's move forward. So therefore, the linear polynomial ax plus b, where a not equal to 0, has exactly 1, 0, namely the x coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. So it is the x coordinate of that point at which the graph cuts the x-axis. So here we had seen this is the point at which the graph was cutting at the x-axis, that is minus 3 by 2 comma 0. So this value of x will be the 0 of the polynomial. The value of x here is minus 3 by 2. Is it clear, students? Now let's go ahead and understand the graph of quadratic polynomial. So when you plot the points y is equal to x square minus 3x minus 4. So when you put x is equal to minus 2, so you will have 4 plus 6, 10 minus 4 will give you 6. So minus 2 comma 6, this is the first point. At x is equal to minus 1, the value is 1 plus 3, 4 minus 4 is 0. So this point. Similarly, at x is equal to 0, this is the point 0 comma minus 4. At x is equal to 1, you will have 1 comma minus 6. At x is equal to 2, you have 2 comma minus 6. At x is equal to 3, we have 3 comma minus 4. And x is equal to 4, we have 4 comma 0. And at 5, we have 5 comma 6. Now you can see that these points, they can never lie in a straight line. So what we'll do, we'll join these points by freehand drawing with a curve. So if you draw this curve here, this is the curve which you will be able to make, right? So graph of a quadratic polynomial is called parabola. There it was a straight line, here it is a parabola. Now parabola can have two shapes. One would be mouth opening upward, other is mouth opening downward, right? These are the two shapes. Now when mouth is opening upward, this is where, so if we have a quadratic polynomial ax square plus bx plus c, if this is the quadratic polynomial, so mouth opening upward when a is greater than 0 means coefficient of x square, if it is positive, the mouth will be upward. And if a is less than 0, that is when the coefficient of x square is negative, then you have a parabola with mouth opening downward. Is this clear, students? Are you able to understand how to make a graph of quadratic polynomial? You will not be asked to make it, but yeah, uh, you should know the name of that curve. This is called parabola. The name of the curve is parabola. And there are two different ways to represent a parabola. One is mouth opening upward, other is mouth opening downward. So when the coefficient of x square, which is a, if it is positive, the mouth will be opening upward. When coefficient of x square a, which is negative, then the mouth will be opening downwards. Clear? So in boards, there was one question 2 years back when they had asked, what is the graph of a quadratic polynomial? It was in MCQ. So parabola was the answer for that. And 3 years back, there was one more question where in the boards you had a question where they had asked that what is the shape of the parabola when a is greater than 0? There were four shapes which they had drawn. And similarly, for a less than 0, what was the shape? Clear? Is this concept clear, students? Have you able to understand it? Okay. And have you noted this down? Shall I move ahead? Okay. Now, geometrical meaning of the zero of quadratic polynomial. So for any quadratic polynomial ax square plus bx plus c, a not equal to 0, the graph of the corresponding equation y is equal to ax square plus bx plus c has one of the two slopes, either open upward or open downward, depending on whether a is greater than 0 or a less than 0. So when a greater than 0, it will be like this. When a less than 0, it will be like this. Open upward is this, and open downward is this second one. These curves are called parabolas. Is it clear? So for any quadratic polynomial, the zeros of quadratic polynomial ax square plus bx plus c, where a is not equal to 0, are precisely the x coordinates of the points where the parabola representing ax square plus bx plus c intersects the x-axis. Right? So quadratic polynomial, the zeros of quadratic polynomial are precisely the x coordinates of the point where parabola cuts the x-axis. So there are three cases here, students. First is when the parabola cuts it at 2 points, so there will be two zeros, this and this. Second is when it just touches it and goes ahead. Here there is only one zero. Third is when it does not touch the x-axis at all. So here we have two zeros. Here we have 1 0, and in this case we have no zeros. Is it clear to everyone? When the parabola cuts the x-axis at 2 points, there will be two zeros. When it cuts at 1 point or touches at 1 point, there will be 1 0. And when it does not touch the x-axis at all, there will be no zeros. Clear, students? Is it okay? You have understood the concept? Okay. Let's move ahead. Now two zeros of the quadratic polynomial. As I said, number of zeros of a polynomial is the maximum number of zeros which a polynomial can have is equal to the degree of that polynomial. Now since the degree of a quadratic polynomial is 2, so maximum number of zeros which a quadratic polynomial can have is 2. It can have 1 also, it can have 0 also, which we saw here. So two zeros of the quadratic polynomial. Here the graph cuts the x-axis at 2 points, here at these 2 points, and second one is at these 2 points. So there are two zeros in this case. Clear? Now second case is here the graph cuts the x-axis at exactly 1 point. So there will be 1 0 here, right? At this point as well as this point. There are these two cases. So here the graph touches the x-axis at only 1 point. Here also the graph touches the x-axis at only 1 point. Third case is the graph is either completely above x-axis or completely below the x-axis. Here the graph does not intersect the x-axis, and that's why here we have no zeros, and here also we have no zeros. Clear? So in quadratic polynomial, we will have either no zero or 1 0 or maximum of two zeros. Maximum number of zeros possible in a polynomial is equal to the degree of the polynomial. So if it is a degree 2 polynomial, maximum number of 0 will be 2. If it is a degree 1 polynomial, maximum number of 0 will be 1. Similarly, if it is a degree 3 polynomial, maximum number of 0 will be 3, and so on. If it is a degree n polynomial, maximum number of 0 is n. So if you can see here the graph, now locating the points of the table on a graph. So this is an example of cubic polynomial. See, this is degree 3. So this is cubic polynomial. So in case of cubic polynomial, we are seeing three cases. So if you draw the graph, here the graph cuts the x-axis at 3 points. It intersects the x-axis at 3 points. So number of zeros here is 3 zeros. Clear? Now here in this second case, the graph touches the x-axis at only one point, that is here. So here you will have 1 0. Similarly, there is third case where the graph cuts the x-axis at 2 points. So you can see here, this is one point and this is another point. So x-axis is being intersected at 2 points. So there are two zeros here. Here at one point, so only 1 0, and in the first case, there are 3 points where it intersects the x-axis. That's why it has three zeros. Is this clear, students? So a cubic polynomial can have maximum of three zeros, right? So there are three cases which you can see having three zeros, two zeros, or 1 0. Shall we move ahead? So number of zeros of a polynomial of degree n. So in general, if there is a polynomial px of degree n, the graph y is equal to px intersects the x-axis at most n points. So therefore, a polynomial px of degree n has at most n zeros. This is very important. Please note this down. So students, just note this down and then I'll give you an homework from the platform, whatever we have done today. Okay. So today's homework would be you have to do the chapter practice of the first chapter, that is real numbers. Okay, because we have not covered a significant amount of things, right, in today's class. So that's why polynomials we don't have to practice today. You have to do a chapter practice of real numbers. Is it clear? So thank you, students. So thanks for joining in today. We'll meet again tomorrow and we'll continue with this chapter polynomial. So tomorrow we'll do questions on geometrical representation of these zeros of a polynomial, right? And then we'll go ahead and complete the second exercise. Okay. So thank you, students. Thanks for joining in. Bye and take care. Have a very nice day.